Hi there, welcome to my channel. Today we continue to solve the Precalculus for Final Exam 3. So let's start it. The question, graph the function below and give the domain and range. So the three things to do here. First of all, we graph, then the domain and the range. So let's start by graph this function. What I can do here, before that I give you a review about the absolute value. We know as the absolute value of x equal x if x more than 0 and minus x if x less than 0. So here we can divide our interval on two parts, the first part and the second part. So let's see gx here, small table, in 0 and 1. The image of 0 equals 0, the image of 1 equals 1, because gx here, absolute value of x equal x. So this is the first one. Next one, if x negative, x gx here. So I put also 0 and minus 1. So the image of 0 equals 0 and the image of minus 1 equal 1, because the absolute value of x in the negative part is minus x. Minus 1 equal 1. So I plot our graph of g here. So for the positive part we have 0 0 and 1 1. Here the first part of our graph. The second one here 0 0, this first point. The second point minus 1 1. Here minus 1 1. Here this point. So first look for this graph. This is the graph of g. This is the yx, and this is the x-axis. So the domain is R, all a real number, integer number, and the range here, the range equal the positive part here, this positive part. So equal 0, infinity. This is the range of g. So we answer for first part of question, graph the g, the second question domain, and the third part of question the range. Let's move for another example. So here hx equal absolute value of x minus 2. So what I can do, the same part here, I find the when equals 0 here, the value absolute when equals 0, so x equal 2. So in the point x equal 2, the sign of g of h change. What I can write another expression of a, so equal x minus 2 if x more than 2, and minus x minus 2 if x less than 2. So I find the first one, x more than 2. I take the 2, another number more than 2, for example 3. The image of 2 equals 0 here. So the image of 3 minus 2, so h3 equal 3 minus 2 equal 1. So here equal 1. If I find the next one, h in the negative part, or not negative part, more the x less than 2, what I put here, 2 also, but another number less than 2, for example 1. So h2 equal 0, but h1 equal minus 1 minus 2. Here equal 1 minus 2 equal minus 1, minus 1 equal 1. Here equal 1. So I plot the graph of h here. This y-axis and this one is x-axis. 1 here, 2, this 2. But for the first one here, 2, 0, 3, 1. For example, here 3, 1. Okay, this is the first part of graph of h. The second part, I take this point 2 equals 0 and 1, 1. Here 1, 1. So it will be in 2 here. So this is the graph of h, hx. Okay, so now I move to find the domain of h equal r equal minus infinity, because we don't have any number to exclude, to deleted or not put in the image of h. Look for the range of h equal in the first part from 0 to infinity, from 0 to infinity. So let's move for another example. Here, this quadratic function, fx equal absolute value of x squared minus x minus x. How can I do for this one? First of all, fx, I change the expression of fx equal x. So here, when the point equals 0, so if I find the two number, the third term here, minus 6, it will be minus 6 equal minus 3 times 2 or minus 2 times 3. So when we add minus 3 plus 2 equal minus 1 and minus 2 plus 3 equal 1. So what is the right option? This one, this right option, because in front of x it is minus. So here I put minus 3 and x plus 2. So what is the point when intercept the x-intercept? Here a point x minus 3 times x plus 2 equal 0. So x here minus 3 equal 0, or x plus 2 equal 0. Here x equal 3 and x equal minus 2. So we have, when we plot the x-axis and y-axis, x-axis and y-axis, here 3, 1, 2, 3, and minus 2, minus 1, minus 2, this 2 point. So when you plot our graph of f here, here minus 6, if x equal 0, f 0 equal root x 6. So when you plot, I give you my, you understand what I can do here without absolute value. Here equal minus 6. So when you here minus 6, let's plot, and so here in the with absolute value, it will be this part in the positive part, change in 6 here 6. So here 6, this is the absolute value of this, not include in our graph. So this not include in our graph. So what we can do here in this step, domain of f, df equal r equal minus infinity, infinity. And for the range of f equal from 0 to infinity, 0, infinity. Okay, let's move for the last one, last example. Vx equal 2 exponent x, this exponent. So what I can do here for this function, we know that any exponents, they go through 0. When you v 0, 0 equal 2 exponent 0 equal 1. Here, 1. So the asymptote, it is here not it is x-axis, here x-axis, the asymptote in this case. So for I can make some value of x, for example, minus 1, 0, 1, 2, and so on. So Vx here minus 1 equal 1 out 2, 0, 1 equal 2, here 4. So when x goes minus infinity, the graph of v not meet the x-axis, not touch the x-axis, but goes under, or not under, but not touch the x-axis here. So when you move minus infinity, the graph of v not takes the point or intercept the x-axis, but here plus infinity. So the df, domain of f, equal minus infinity plus infinity. About the range of v, the v, range of v, I remove the 0, infinity. Because, why? Because the graph don't intercept with the x-axis here in this point. When you goes minus infinity, x goes minus infinity, don't intercept any point of x-axis. So this the last example of our explanation. Thank you, and keep learning. See you in the next video.